So let's solve the following inequality. So here we have the absolute value of x minus 2 is lying between 1 and 3. To begin with, let me state quickly the definition of an absolute value. So absolute value of x is defined as positive x if x is greater than 0, and it's going to be negative x if x is less than 0. Meaning, if we have absolute value of 2, so since 2 is this is going to be equals to 2 since 2 is a positive number. Then if we have negative absolute value of negative 2, then this is going to be equals to negative of negative 2. Because here we have negative 2 which is less than 0, and that immediately follows that we have to take the negative of that particular value. So negative of negative 2 is going to give us positive. So that means regardless of the sign of the argument, the absolute value is always going to be equals to 2. Now we'll use this definition to solve the given linear inequality. Let's take the first case number 1. Case number 1, let's say if x minus 2 is a positive number, then in that case our inequality will become 1 less than or equals to x minus 2 less than or equals to 3. Now we'll solve this. What we'll do, we'll add 2 to throughout the inequality. So we have x minus 2 plus 2 less than or equals to 3 plus 2. So we have 3 less than or equals to x less than or equals to 5. So here we have one solution which says that x must lie between 3 and 5. So if we want to express it in interval form, so we have x lying between 3 and 5. Now let's talk about the second case. In the second case, we will consider if x minus 2 is a negative number, x minus 2 is less than 0. So that means we have absolute value of x minus 2 will get replaced with negative of x minus 2, and this is lying between 1 and 3, which means we have 1 less than or equals to negative x plus 2 less than or equals to 3. Now we'll subtract throughout. So with 2, so we have 1 minus 2 less than or equals to negative x plus 2 minus 2 less than or equals to 3 minus 2. The 1 minus 2 will give us negative 1 less than or equals to negative x less than or equals to 1. Now here we have the coefficient of x as negative 1, but we want to make it positive 1. All we have to do is multiply throughout with negative 1. But here we'll have to be careful. That means, let's say we have 3 numbers, a, b, and c. A is less than or equals to b, and b is less than or equals to c. And let's say we have another number, d, which is a negative number. Then if we multiply a with c, a with d, the negative number, b with the negative number, and also c with the negative number, then the sign of the inequality changes. That means AD will become greater than equals to BD, and BD will be greater than or equals to CD. So similarly, what we'll do, we'll multiply throughout with negative 1. So we have negative 1 multiplied to negative 1. So this will become greater than or equals to negative 1 multiplied to negative x, greater than or equals to negative 1 multiplied to 1, which simply gives us 1 greater than or equals to x greater than or equals to negative 1, but we'll write it in the ascending order. So that means we have negative 1 and less than or equals to x less than or equals to positive 1. Or in the interval form, we have x lying between negative 1 and 1. So that means the solution to the linear inequality will be x belongs to the interval negative 1 to 1 union 3 to 5. So this is the solution set to the given linear inequality.